Okay, so on Proofs Worksheet 4, we're looking at complementary angles, which means two angles that add up to 90 degrees, supplementary angles, which is two angles that add up to 180 degrees, and the linear pair postulate. So before we go into these proofs, let's look at our proofs resource page. So something I want to point out here is actually on the angle page. Let me go ahead and clear it off for us. All right, so down on the angles, if you can turn to that page, I just want to kind of point out the three main things we're using. Everything else is still in play that we've learned, but the three things this is kind of focusing on today. So first of all is the definition of complementary angles. So that's right here. So to use the definition of complementary angles, you need to know that two angles are complementary. So they'll state, for example, angle 1 and angle 2 are complementary. If they are, then you can make this statement. Measure of angle 1 plus measure of angle 2 equals 90 degrees. It also works backwards. If you know the measure of angle 1 plus the measure of angle 2 equals 90, then you can say angle 1 and angle 2 are complementary. It works both ways. So now, the definition of supplementary angles is very similar. If you know angle 1 and angle 2 are supplementary, if you have that statement, then you can say measure of angle 1 plus measure of angle 2 equals 180. And it works backwards also. If you know measure of angle 1 plus measure of angle 2 equals 180, then you can say angle 1 and angle 2 are supplementary. All right, let's go ahead and look at linear pair. That to me is one of the hardest things for students to get. So the linear pair postulate. You have to know angle 1 and angle 2 form a linear pair. So if you don't have that statement, then you can't say, okay, cool, angle 1 plus angle 2 equals 180. So if all I had was an image, like the image shown here, then what I'd have to do in a proof is I'd have to say angle 1 and angle 2 are a linear pair. And how you know that is because it meets the definition of linear pair. So first you have to have the statement that angle 1 and angle 2 are a linear pair. If it was given, you write given. But if you just assumed it from the picture, then you write it out, and the reason is definition of linear pair. From there, you can use the linear pair postulate because you know angle 1 and angle 2 form a linear pair. So now you could say measure of angle 1 plus measure of angle 2 equals 180. And sorry, that's degrees. And that is the linear pair postulate. So we're going to see that a lot. I'm going to refer back to this quite a bit through all of our different proofs. So let's take a look at the first proof. So it says given angle AEB is a complement of BEC. So they wrote it on line 1 and they wrote given. So far so good. Now the key word is complement. So remember, we have on the angles page, we have about angles, we have definition of complementary angles. So if you know two angles are complementary, you can say they add up and equal 90. So we're going to say, cool, if AEB is complement of BEC, then measure of angle AEB plus the measure of angle BEC equals, let's see, that would be 90 degrees because it's complement. And that's definition of complementary angles, like line 2 says. Okay, now let's look at line 3. They said measure of angle AEC, that's this angle right here, and it equals the measure of angle AEB plus BEC. So that is just two angles added together equal the whole angle. That is the angle addition postulate. So when you add up two angles that are adjacent and they equal the whole angle, that's angle addition postulate. Okay, so now if we have angle AEC equals 90, well, so they never said measure of angle AEC is a right angle. They didn't state that, so we can't use definition of a right angle. There's no box drawn on the picture like that for us to be able to assume. That's not on there. So it must have somehow figured that out from the lines above line 4. So somewhere between lines 1, 2, and 3, we came up with AEC equals 90. So where I see it happening, AEC is right here. So this is AEC. All right, so that came from line 3. Now the 90 I see on line 2. Do you guys see that AEB plus BEC equals 90? So AEB plus BEC equals 90. Well, on line 3, we also have AEB plus BEC. So if they equal 90, then I can take the 90 degrees, oops, sorry, I'm a highlighter. I can take the 90 degrees and substitute it in for all of this highlighted stuff. So they use substitution. So I'm going to put substitution, and they took the 90 degrees from line 2, and they plugged it into line 3. They swapped out the yellow highlighted part of AEB plus BEC. They traded it out. They substituted for 90 degrees. So that's where line 4 came from. Okay, now, angle DEA and angle AEC are linear pairs. So the key word there is linear pair. So if we go back and we look at our angle sheet, so we have two different things of linear pairs. So if you're just making the statement that two angles are a linear pair, this can be assumed from an image or from a picture. So you can see two angles that form a line and call them a linear pair. That's what we did there. We don't have the linear pair postulate because the linear pair postulate, you would have this statement first and then be able to go here. So we're going to use the linear pair postulate in a minute. But what we have here, just stating the two angles are a linear pair, that's the definition of linear pair. Because what they did is they looked at the picture and they said, hey, DEA is this angle right here. And then they said AEC, that's this angle. And they're like, hey, those are linear pairs. And we can tell that from a picture. So now, because they had the statement that they are linear pairs, they were able to then say, if DEA and AEC are linear pairs, then the measure of angle DEA plus the measure of angle AEC equals 180. And that's because of the linear pair postulate. So remember, you have to have this statement that the two angles are linear pairs to then make this statement. And that's what the linear pair postulate lets you do. It lets you go from line 5 to line 6. And that's what that one does. Okay, so now 7, it says we're using substitution. So I'm going to look at line 8 to see what I need to have in my problem, because somewhere in there I'm going to need some type of substitution. So if you look at line 8, we'll highlight like real light over here. Let's do it in this kind of gray color. So if you look at line 8, they have angle DEA. Okay, that was in line 6. So we probably need it in line 7 if it's staying. And then the 90 is new. They had AEC and 180. So far what I know is that if in line 6 they had DEA and they have it in line 8, we probably need it in line 7. So somewhere we have to substitute something. So I see on line 4, we know that AEC equals 90 degrees. So my guess is instead of AEC, they're going to substitute in 90 degrees and keep the 180. So that was taking line 4 and substituting it into line 6. So now, how do you think that they have DEA and they get it to equal 90? Somehow, how do you think they're going to move this plus 90 degrees? All right, so they're going to subtract it. So if you subtract 90 from both sides, you're going to end up with DEA equals 90 degrees. So that's the subtraction property of equality. All right, let's try another one. So first are our two givens. Angle 1 and angle 2 are supplementary. Angle 3 and angle 4 are supplementary. Now, I also notice we have a third given right here. Angle 2 is congruent to angle 4. But notice on line 6, they have it written down. So they have all three givens written somewhere in our proof. So we're good to go on givens. So the key word on the first two givens is supplementary. So that tells me, hey, we're probably using the definition of supplementary angles. And so if you look that definition up, then what you have here is it says if you know two angles are supplementary, angle 1 and angle 2 are supplementary, then angle 1 plus angle 2 equals 180. That's what the definition of supplementary lets me say. So if I know on line 1, angle 1 and angle 2 are supplementary, then I can say the measure of angle 1 plus the measure of angle 2 equals 180. The same with line 2. If 3 and 4 are supplementary, then I could say measure of angle 3 plus the measure of angle 4 equals 180. And that's using the definition of supplementary angles just twice. Okay, line 5 says we're using substitution. So look at where this came from. So first of all, on line 5, we have angle 1 plus angle 2. Okay, we saw that on line 3. We also have angle 3 plus angle 4. And here's where we see that on line 4. So what I think they did is I think they took this angle 3 plus angle 4, and I think they took this and they were like, hey, if that equals 180, you can take out this 180 and write it instead. So that's substitution. And so that's taking line 4 and plugging it in to line 3. So line 4 into line 3. Okay, here's their given. So they're just using up their given. They could have used it at the beginning, but I think they were thinking, hey, I'll use the givens and do things with them until I get stuck, and then I'll use the third given. So angle 2 congruent to angle 4 is given. So now on line 7, they say measure of angle 2 equals to measure of angle 4. So all they did was they took line 6 and they changed it from congruent to equals. So changing something from congruent to equals but changing nothing else is the definition of congruence. You could also put definition of congruent angles. Okay, 8 gets a little funky. Line 8 down here seems to have a lot happening. So it looks very similar to line 5. Let's compare it to line 5 and just see what do these things have in common. All right, so if I look at line 5, I had measure of angle 1 plus measure of angle 2. All right, I still had measure of angle 1 plus measure of angle 2, so that's not different. And I had angle 3, here's angle 3. But what's different here is instead of measure of angle 4, now I have measure of angle 2. So it looks to me like they swapped something out. So what I think they did was instead of angle 4, I think they were like, hey, on line 7, angle 2 equals angle 4. So therefore, I can trade them out, and that's substitution. So they took and they substituted, and they took line 7, angle 2, and they plugged it in to line 5, where angle 4 is. So they just swapped it out. So right there, they were like, nope, go away, angle 4. We're writing angle 2. And that's fair because they said angle 2 and angle 4 are the same thing. So they can be traded out anytime. Okay, so now we've got to figure out somewhere along the way, we've got to get down to angle 1 and angle 3 on line 10. So if you look at line 8, here's angle 1, here's angle 3. So I need to get rid of this plus angle 2 and this plus angle 2. How could you, what is the opposite of adding angle 2? All right, it's subtracting angle 2. So you could subtract angle 2 from both sides, and you'd be left with angle 1 is equal to angle 3. So that's subtraction property of equality, because you're subtracting the same thing from both sides. Okay, now you're going from angle 1, oh, sorry, I wrote that wrong, from angle 1 equals angle 3 to angle 1 congruent to angle 3. So you're just switching from equals to congruence. And when you switch from equals to congruence or congruence to equals, that's the definition of congruence.